Okay, so this video here is for Algebra 1. We have a Chapter 3-4 summative assessment on Monday. So here's an extended response question to help you out. So it says, and again, I invite you to look through or go piece by piece, stop, try it yourself, and then press play and see if it matches mine. High demand cars that are also in low supply tend to retain their value better than other cars. The data in the table is for a car that won a resale value award. Okay, so it shows the year and then how much it's still worth, what percent of its value it still has. Write a function to represent the change in the percentage of the car's value over time. Assume that the function is linear. So there's a couple things here. Number one, write a function to represent the change in the percent over time. So we have two units here, year and value. Year is going to be your x and value is going to be your y. Okay? And number two, it is assumed that it's linear for the first 5 years. So what I'm looking for is a linear equation. We know linear equation. Y equals mx plus b. I need to create an equation in slope-intercept form that matches this data. Well, to do that, I need to find the slope and the y-intercept. Well, what do they give me? They actually give me 3 points. These are 3 x and y values. Well, let's choose 2 of them. Let's choose the first and the second, and let's find the slope between those two. So in this table here, let's let 1 be x1 and 84 be y1. Let's let 3 be x2 and 64 be y2. So my slope formula is slope equals, I'll do it here in orange, y2 minus y1 over x2 minus x1. That is 64 minus 84 over 3 minus 1. That's going to be negative 20 over 2, which is negative 10. And that's my slope. That's m. So now I'm going to use m, the negative 10, and one of these points, let's say 184, and I'm going to plug them into slope-intercept form to find my y-intercept. So again, y equals mx plus b. Y is 84, m is negative 10, x is 1, and my plus b. This is 84 equals negative 10 plus b. I can make my b's better. And I'll add 10. 94 equals b. And now I'll take my b and I'll take my slope and we'll come over here to create my equation. Y equals negative 10x plus 94. Alright, so next we're going to say, according to your model, by what percent did the car's value drop the day it was purchased and driven off the lot? Okay, so let me write this down. So the equation, the model I have is y equals negative 10x plus 94. So this is the very day that you purchased the car. Well, what does that mean? The very day you purchased the car, so this very day, means your x value is 0 years. So we need to plug in 0 and see what happens to our percent value. We'll plug in 0. Y equals negative 10 times 0 plus 94. Y equals 94. So what is this? This is the y-intercept. So when x is 0, you're finding the y-intercept. So I could have just looked at my equation. But what does that mean? That means 94% value left. So the question is, according to your model, by what percent did the car's value drop? So if I have 94% value left, then subtract that from 100. 100 minus 94 is 6. I have 6% value drop. So that means the very second you leave the lot, your car just lost 6% of its value. How crazy is that, right? But that's the real world. Okay. Alright, next. Do you think your linear model would still be useful after 10 years? Explain why or why not. Well, let me write down my model. My model is y equals negative 10x plus 94. Well, 10 years, that would just mean x equals 10. Let's see what happens when we plug it in. Y equals negative 10 times 10 plus 94. What does that simplify to? That simplifies to negative 6. That means that after 10 years, my car would be negative 6% its value. Well, does that make sense? No. A car can't drop below 0%. So, could this still be useful? No. Because the percent value should not drop below 0. Even if I have a rusty old, junker that doesn't even run, it might still have a part that's worth something. Okay, so there. Okay, and then the last part. And again, notice we're using this, the same equation all the time. So now, part D. Suppose you used months instead of years to write a function. How would your model change? Well, let me go back to the top real fast. So the original model had 1 year, 3 years, and 5 years. So I'm going to create a new table, and I might have to go up and down. So it's now going to be months, and there were 3 sets, and now it's going to be up value in percent. So I think it was 1, 3, and 5. So 1 year is 12 months, right? So I'll write that over here. 1 year is 12 months. So 1 year is 12 months, 3 years is 36 months, and 5 years would be 60 months. And I believe it was 84, 64, 44. Those are the values. So the question is, if I try to use months as the x's, right, how will the linear function change? Well, let's do that. All right, month is still x, value is y. Let's use these 2 data points again, and let's do the whole part A again. Find the equation of the line in slope-intercept form. Y equals mx plus b. Find the slope first. y2 minus y1 over x2 minus x1. That is going to be 64 minus 84 over 36 minus 12. That's negative 20 over 24. And if you divide it out, it's fine, but that actually does simplify to a nice number. You can divide each of these by 4 to get negative 5/6. Or you could have the decimal, which is negative 0.83. So that's the m. Either one of those would work. I'm going to use the fraction, but again, it's a word problem. I've told you use decimals with word problems, so go for it. So now I'm going to take this slope, and I'm going to use the first point and find my b value. Y equals mx plus b. Y is 84. Equals m negative 5/6 times 12 plus b. This 12 goes to the top only, so this is 84 equals negative 60 over 6 plus b. This simplifies. This is 84 equals negative 60 over 6 is negative 10 plus b, and I'll add 10. 94 is b. And now I will take my slope, and I'll take my y-intercept, and I'll come over here, and I'll write my equation as y equals negative 5/6x plus 94. So, what changed, right? How would your model change? The slope changes. But the y-intercept is the same. So again, it doesn't matter if I'm in months or years. When I drive the car off the lot, it's still going to be worth 94% of its value. That is independent of time. But of course, the slope, which is per time, is going to change if it's per year or if it's per month. Okay. Okay. So this is a great question. If you were able to understand this and do it well, good job. Feel confident going into Monday. Thanks for watching. I'll see you on Monday.